Thank you, Dr. Lee. Thank you for organizing this once again. Excellent job. We appreciate that. And I guess just quickly introduce Katie. I don't think you got introduced, did you?
I think you by yourself.
Okay, so we have our sales distributor, Ace Tech, with Katie Kim. And you probably know everyone, but anyhow. And DH, behind the camera. So thank you for your help too.
Speak slowly and more.
Project. Okay. All right, so welcome to the NSSC Listen seminar. Today we're going to be talking about digital audio measurements, high resolution audio testing, car audio distortion measurements, and linear resonator actuator testing. So we're going to divide this up between Mac and myself. Mac is going to be presenting the digital audio, and then there will be a break. I will discuss high resolution measurements, and then there will be lunch, and then I'll go into car audio distortion measurements, and Mac will finish up with the linear resonant actuator testing. And feel free, if you don't understand something, to raise your hand, ask a question. Don't be shy. I don't understand Korean, but these guys do, so they can ask. All right, so I'm going to hand it over to Mac. There's a laser pointer here for me.
Thanks.
So Mac's just going to do a quick introduction of Listen.
Thanks, Steve. Hello, everyone. My name is Mac Liu. I'm the International Sales Manager for Listen. I actually am Chinese American. I speak Mandarin Chinese. Unfortunately, I do not speak Korean. But I love coming to Korea. The food is excellent in Korea. So it's never hard to come here and enjoy the food and meet our customers. Some of you already know who Listen is and what we do, but maybe some of you don't. So I'll spend just a few minutes explaining who we are as a company and our product. So essentially, the history is very interesting. The company was founded 21 years ago by Steve Temme. He was an audio engineer for Brew & Care. Many of you probably know who they are. He has hats made by Brew & Care. They make very nice audio equipment. It's from Denmark. So everything is very expensive and very good. He was a product engineer for the 2012 audio analyzer. At the time, he realized that there's a lot of opportunity to change the way audio is measured, or acoustic transducer can be measured. Instead of a very expensive front-end equipment, you can use a simple computer, because the computer is getting faster and faster, along with a audio interface sound card that is a very good, basically a very good audio to digital, analog to digital converter. You can make the same measurements using a computer, an audio interface, and a microphone. You can measure all the same things that an expensive equipment could be made to measure. So that's when the first generation sound check system started. And this was over 20 years ago. And now we're at version 15 that just released 2 weeks ago. And we've been very successful. The production facilities in China for anything acoustic transducer related, microphone, speaker, whether it's digital MEMS or traditional analog, there are thousands of production lines using SoundCheck. And when we started as a company, the initial product is just SoundCheck. That's software. And as time went on, our customers demand more and more solutions from us. And now we have a whole full suite of hardware to go along with our software. And the Listen hardware is designed now to work seamlessly with the SoundCheck software. It's essentially a turnkey solution where the hardware you see in front of you here, some of the hardware is here. For example, this is a 2-channel audio interface, and when this connects to SoundCheck, it automatically detects this hardware and sets it up inside the hardware editor. Essentially, it knows what the sampling rate is, it knows what the VP value is, it knows the latency, it knows the serial number. So you don't have to set up the hardware on your own, it's automatically done for you. Here is a power amplifier, and here is a 2-channel microphone power supply. So we have and also this is a product called BTC 4148. This is a interface made for us by a company called Portland Tool and Die. And this is a Bluetooth interface. It also is designed to work seamlessly with SoundCheck. So, not only do we have software, SoundCheck, we also have a whole full suite of hardware. So talk a little bit about SoundCheck. Why is it a good product? Why is it so popular to use? Most of our customers have R&D somewhere outside of where all the factories are, which is now typically in China. So the R&D folks can use SoundCheck to design a test process. So what we create from SoundCheck in that test process is what we call a test sequence. It's a step-by-step testing procedure. Take the first step to load a stimulus, take the next step to play it back, and then acquire the signal, and then you do analysis. So it's a step-by-step process. It's a single electronic file, and it's a test sequence file. Once you've set it up, you can send it to your factory anywhere in the world. As long as they had SoundCheck, the same test could be run in the factory as you would back in your R&D laboratory. So for the R&D folks, it's a very accurate program. Has a lot of speed and lots of available logarithms for measurement, and it's also very flexible. It's a modular-based system. If you need a certain measurement, you can buy the specific module you need. If you don't have that requirement, you don't need to get that module. So it's very flexible. And for the factories, because of our algorithms, it's very good with rejecting background noise in a factory. In China, the factories are very noisy. Our algorithms have very good noise immunity. It's also very fast. You can run a test in just 2-3 seconds. And it could be automated. We have a lot of options for controlling SoundCheck from the outside, meaning you can use RS-232 to control it. You can use a foot switch in a production line to start a test. You can now have TCP/IP control, which is the latest, SoundCheck 15. And you can use TCP/IP control externally into SoundCheck. And the data you get from the testing can be sent out to say a network somewhere, or it can be emailed very easily, exported to Excel. So you have the test set up in your R&D facility. You send the testing to the factory. The factory does the same exact test and sends back to your results, and you can do all the analysis at your location away from the factory. All the data, all the test sequences can be emailed and exported and imported very easily into SoundCheck. So the SoundCheck software itself has basically 3 big parts to it. The first part is what we call interactive troubleshooting. So that's really consisting of what we call a virtual instrument. There are tools like you can set up, you can take a, let's say if you have a problem you want to resolve and you need to know, you need to run an oscilloscope. You can use that in sound check. You can have a spectrum analyzer in sound check. You can have a real-time analyzer, an RTA. You could have a multimeter. So those are very easy tools that you can use to troubleshoot any problems. And that's all built into sound check. The next part is what we call a sequence. Here's a graphic showing a sequence where it's 29 steps. First step, second step, so it's a sequential process of running a test sequence. As it runs through the whole sequence, it completes the test. And if it didn't pass a certain step, it will show up as a green or a red color. So it's very easy to see where it's going wrong and what's going on in the test sequence. And the last part is, so here's a graphic showing the RTA. Here's what we show as the kind of, after you've done a measurement, you want to analyze the data, you can do that in sound check as well. So most importantly, you can have three parts. One is the virtual instruments. You can write the test sequence, and then you could do the data analysis after you've done the testing. Along with the sound check software, we have a full suite of hardware. And I already talked about some of the hardware. We have audio interfaces, very high quality sound cards basically. We have microphone power supplies. We have amplifiers. Here's a DC power supply. So for folks that are using, that needs DC, we have that as well. People who are using it for hearing aids, testing, actually we can use that to do a voice coil offset measurement, the DC connect. We also have things like a digital interface like Bluetooth. The BTC 4148 is a Bluetooth interface. And say if you're working with MEMS microphone, we have that as well. So we have traditional analog hardware as well as digital interface hardware. And we can provide a turnkey solution for your application. Software and hardware combined.